Namaskar. Now we are aware about what is the meaning of gradient of a scalar function, divergence of a vector function, and curl of the vector function. Now in this video, with some example, we will find the gradient, divergence and curl of scalar and vector function. We will begin with the gradient of f, and we will use the function which we have considered in the last video itself. It is 3x square y minus 2z cube. This is our function. Now we will have to calculate this gradient of f. Therefore we will begin with gradient of f is equal to del, that is I dou by dou x plus j dou by dou y plus k dou by dou z, and we will have to operate this on the function 3x square y minus 2z cube. Therefore, using the rule of distributive property, that is, we will have to operate this I cap dou by dou x, then j cap dou by dou y, and then k cap dou by dou z on this function. Means I will have to calculate the derivative of this function with respect to x, and that will be the coefficient of I cap. Therefore, if I calculate the derivative of this, then derivative of 3x square y will be 6xy minus derivative of 2z cube with respect to x is 0. Therefore, this is I cap. Okay, plus. Okay, I will write it here, it is plus. Then we will have to differentiate this with respect to y, and that will be the coefficient of j cap. If I differentiate this with respect to y, then it is 3x square only. Derivative of the second term 2z cube with respect to y is 0, and therefore it is j cap. And for the third term, we will have to differentiate this function with respect to z. Now here the derivative of first part of the function 3x square y with respect to z is 0, and derivative of minus 2z cube with respect to z is minus 6z square. Therefore it is minus 6z square, and that is k cap. Therefore it is very simple, and we can conclude that the gradient of function f, this is 6xy I cap plus 3x square j cap minus 6z square k cap. Fine. Now what is the physical significance of gradient of a particular scalar function? This we will discuss later in some other video. What are the physical significances of the gradient, divergence and curl? For that, at the end of this video, I will give you some functions, some simple functions which have some meaning, and I will ask you to plot those functions using our previous video, with help of our previous video, and then find the gradient of the scalar function, divergence and curl of the vector function. Then with reference to that homework, we will discuss what are the physical significances of this. Now for moving further, what we will have to do? We will have to think about the divergence of vector function a bar, curl of a vector function a bar, with a bar to be equal to, I will consider the same function which we have discussed last time. It is xy square I cap minus 2y cube j cap plus xyz k cap. This is our vector function. Now we shall begin with the divergence of a bar, correct? Therefore what I will have to do? I will have to write the del operator I cap dou by dou x plus j cap dou by dou y plus k cap dou by dou z. It is to be operate on a bar with dot product. Therefore it is x y square I cap minus 2y cube j cap plus xyz k cap. Now already we have observed that as it is dot product, we will have to differentiate the first term, that is the coefficient of I cap in a bar with x, differentiate coefficient of j cap in a bar with y, and coefficient of k cap in a bar with z, correct? Therefore, derivative of x y square with respect to x is y square only. Derivative of minus 2y cube with respect to y is minus 6y square. And derivative of xyz with respect to z is xy. Therefore, this is the divergence of a bar. Now here we can observe that the divergence is the scalar term. It is not the vector term, and it is obvious because it is dot product. Dot product is the scalar product. The resultant is the scalar term. Therefore, though the del operator is vector, a bar itself is a vector, but the divergence, which is the dot product between del and a, is the scalar, and it is obvious. Now we shall proceed with the curl of a bar. Therefore, I will think about curl of a bar. What is curl of a bar? There are two ways. I shall follow the normal way, that is, I will write the del operator dou by dou x plus j cap dou by dou y plus k cap dou by dou z, and then with a cross operation, with a cross product, I will operate this on the function, vector function a bar, that is x y square I cap minus 2y cube j cap plus x y z k cap. Okay. Now again I can say that I cap cross I cap is 0, and therefore there is no meaning to calculate the derivative of this first term x y square with respect to x. But when I operate this I cap dou by dou x on minus 2y cube j, it has meaning. Therefore, I will have to differentiate minus 2y cube with respect to x, and that is 0 because it is y is to be constant. I am differentiating with respect to x. Therefore, I will have to treat y and z to be constant. Therefore, it is 0. But to understand what will be the direction if it is non-zero, I can think about I cap cross j cap, and that is equal to k cap. Then I will have to operate I cap dou by dou x on plus x y z k cap. That means differentiate this with respect to x, and that is nothing but it is plus y z, and I cap cross k cap, it is in reverse direction. Therefore, actually it is minus j cap. Now initially I have written plus sign here, and therefore I could not absorb this minus sign in this stage itself. I will have to write one more step for that. Then plus I will have to operate this j cap dou by dou y on all these three, but j cap dou by dou y, when I operate this on x y square I cap, it has meaning because j cap cross I cap will not be 0. Therefore, I will find the derivative of xy square with respect to y. It is 2xy, and j cap cross I cap is again minus k cap. Therefore, I will write here it is minus k cap because I have written already plus sign, and I will not cancel it. Then j cap cross j cap will be 0. There is no meaning to differentiate minus 2y cube with respect to y. J cap cross k cap is non-zero. Therefore, I will differentiate this with respect to y, and that is equal to xz, and j cross k is equal to I. Therefore, here it is I cap. Then again I will have to operate k cap dou by dou a z on all these three. I will have to differentiate this with respect to z, and that is equal to 0. Therefore, I will write it is plus 0 because there is no z in coefficient of I cap, and k cap cross I cap is equal to j cap. Therefore, it is 0 j cap. Actually, it is 0, but I will write it here. If I operate this k cap dou by dou z on this, it is minus 2y cube. But again, the derivative of minus 2y cube with respect to z is 0. Hence, I will write it is 0. But k cap dot j cap is equal to minus I cap. Correct? Is equal to minus I cap. I will write it here. And obviously, there is no meaning to think about the last term, that is operation of k cap dou by dou a z on x y z k cap. The reason is that k cap cross k cap is equal to 0. Okay. Therefore, this term will 0. Here I will have to write it is minus yz j cap. Here it is again minus 2xy k cap. Then here it is plus xz I cap, and these two terms are obviously 0. And then rearranging in the order of unit vectors, that is I j k, I can write it is xz I cap minus yz j cap minus 2xy k cap. This is one way, and this is nothing but curl of A bar. The another way to calculate this curl of A bar is use of the determinant we have observed last time. Here I will have to write the first row as I cap, j cap, k cap. The second row is dou by dou x, dou by dou y, and dou by dou z. The third row is the coefficient of A bar. That means it is x y square minus 2y cube and x y z. Okay, once I written this determinant, I will have to solve this. Therefore, what is the coefficient of I cap? Differentiate this with respect to y, this. Therefore, I will write it is xz minus derivative of minus 2y cube with respect to z, and it is 0, plus j cap into bracket. Now I will have to consider in cyclic order. Therefore, first derivative of xy square with respect to z, which is 0, minus derivative of xyz with respect to x. Therefore, it is minus yz, plus k cap into bracket derivative of 2y cube with respect to x, which is 0, and derivative of xy square with respect to y, which is 2xy, correct, which is 2xy. And I will simplify this. It is xz I cap. Here it is minus yz j cap minus 2xy k cap. Now you will observe that the curl with this method, with the method of distribution property, and the curl with help of the determinant, both are same. And it is obvious because the curl of A should be same. It should depend only on the vector function A. It should not depend on the method through which we are calculating this. Okay. Therefore, this is about how to calculate the gradient, curl, and divergence too. Now I will give you one homework. Okay. Find the divergence, the gradient of G. Say for example, I will write here it is find G with G to be equal to simple, it is y square. Okay. Now try to plot this function in Cartesian coordinate system. That means you will have to think about z-axis, this is y-axis, this is x-axis. Therefore, this is x-axis, here it is y-axis, z-axis. Now what I have done? I have considered a very simple function which is in yz plane, because x is perpendicular to plane of figure, and therefore to avoid the complication I have not considered any component along x-axis. Therefore, try to plot this at different points. Say for example 0, then y is equal to 1, all the three components 0. Keep x is equal to 0 for all time, y is equal to 2, then somewhere here, that is z is equal to 1 with xy 0, then x0, y1, z1, somewhere here. Write the values, correct, and prepare the scalar function, which we have done in some previous video, what is the meaning of scalar and vector function. There we have done this. Then I will give you the homework as find the value of divergence of A bar, correct, divergence of A bar with A bar to be equal to y j cap plus z k cap. Again in the same similar, not on the same diagram, but by considering another Cartesian coordinate system, you will have to draw this A bar. That means y j cap plus z k cap. Again we have done this in xy plane. For example, suppose here it is the point 0 1 1, then 0 1 1, that is 1 j cap plus 1 k cap. It is 1 j cap plus 1 k cap. That means the vector will be along somewhere along this direction from here. This point is 0, 1, 0. Therefore, the vector will be along this direction. Here the vector will be along this direction. Somewhere here the vector will be along this direction. And you will realize that the figure is moving away from the origin. Now if I think about a point 0, 2, 2, then it is 2 I cap, j cap plus 2 z k cap. That means the vector will be of larger length. You will have to plot this and then find the divergence of a bar, because the physical significance we can explain with help of this diagram, and that is homework for you. Similarly, find the value of curl of b bar, correct? Curl of b bar with b bar to be equal to minus z j cap plus y k cap. And again in the third diagram, Cartesian coordinate system, you will have to plot this, correct? You will have to plot this. How? In the same figure, if I will have to plot this, then I can say that for this particular point, that is 0, 1, 1, 0, 1, 1, it is minus 1 j cap and it is 1 k cap, correct? It is minus 1 j cap, 1 k cap. Therefore, the vector will be along this direction. If I think about this point, that is 0, 0, 1, 0, 0, 1, then it is minus 1 j cap. Therefore, the vector will along this direction. And you will have to plot this in the third diagram of Cartesian coordinate system. And then you will have to find the curl of b bar. Okay. In the next video, with reference to the gradient of g with g to be equal to y square, divergence of a with a to be equal to y j cap plus z k cap, and curl of b bar with b to be equal to minus z j cap and y k cap, we will discuss the physical significance of gradient, divergence and curl. Thank you.